Well, good afternoon, good morning, and good evening, everyone. My name is Frank Fillmore. I think we're ready to get started with our webcast. I appreciate everyone joining us today. There's obviously quite a lot of interest about this topic, so we'll go ahead and get started. Joined by my colleague, Kim May of the Fillmore Group. Say hello, Kim.
Hello.
And just to annoy Kim to no end, I want to point out to all on our webcast today that Kim is doing this on her birthday. So if in the chat, if you could wish her a happy birthday, that would be grand. I have everyone on mute. If you have questions, please use the chat function so we can see your questions. I'm going to pause occasionally to be able to take those questions and answer them as we reach the end of a section. So getting started, 45 minutes to understand IBM replication. Our agenda today is an introduction, why we're here, what we plan to talk about, and who we are. We're going to do a review of replication. Why do we need replication? What is that about? And then the competitive landscape. Other vendors besides IBM offer replication products, so why do we care about those, and what do they offer, and where does IBM excel? We'll talk about IBM's replication products and then the components of those products, the feature functionality that are going to be supplied. We're going to talk about sources and targets, where the data comes from and where it goes to, so we can meet the business requirements you have to provision data where it needs to be in the format it needs to be in to meet your business requirements. We're going to talk about key features of IBM replication and some upcoming enhancements. And we'll talk about remote capture for vSAM and something new called integrated synchronization. We'll talk about tooling, which is a bit of a hash, but we'll step through it. There have been some changes and continue to be changes in that area in terms of IBM replication monitoring and administration. We'll talk about decision criteria. How do you decide what to deploy in terms of a replication solution? How you consume that from your vendor if you choose IBM, and resources to help you on your journey to get the best possible value out of your replication investment. So a brief introduction, who we are, the Fillmore Group. We were founded in 1987, so we're 33 years young. We've been an IBM business partner since 1989. We have been delivering IBM authorized education since 1994. I'm what is known as an IBM Gold Consultant. I entered that program in 1998. There are about 40 of us worldwide. And if you have questions about what a Gold Consultant is, you can click on that link. And both Kim and I have been IBM champions since 2009. And an IBM champion is someone who blogs or tweets or serves in the community. Kim was for many years on the board of the Baltimore Washington DB2 Users Group and led that board for 2 or 3 years and present webinars like this one. So now that you know who we are, I'm going to find out a little bit more about you. So I have a series of polls, and I'm going to the first one right now. Is your organization currently using replication in a production environment? So I'm going to go ahead and open our polls, and I'm going to launch the first one. So if you could take a moment and respond. And not surprisingly, more than 3/4 of you, as you are responding, are saying that, yes, we're currently using replication, which is probably one of the reasons that you wanted to invest an hour this morning.
Okay. So Frank, your question was a yes/no question for people whether or not they're using replication. But I think to make sure everyone reframe this properly, we want to make sure everyone understands that we're interested in whether or not you're using replication. We assume you all need to use replication, but we're particularly interested in people that aren't using IBM replication or are interested in learning more about IBM replication.
Understood. Yeah, that's the purpose. And we have some more questions along those lines coming up. And that brings us directly to our second poll, which is which replication solutions are you in use right now in your organization? So if you answered yes, you have it in production, tell us what replication solution is currently in use that you're trying to meet your replication requirements with. And we'll take a second to let everybody answer that. And again, not surprisingly, about 3/4 of the folks are currently using IBM Replication, but we see a lot of Golden Gate, and we see a lot of other. I'd be curious about that much more than I had anticipated. So this is very useful for us to help guide our discussion today. So for some folks, this is going to be a catch-up. For some folks, maybe, a good third. And again, the numbers add up to more than 100% because you may have more than one solution. That's why it was a multiple choice. Still getting answers in, so we'll give people a second to do that. So we have most of our housekeeping out of the way. So why do we replicate data? So from the IBM perspective, there are two primary reasons, and they label those business in real time, business in real time, and always on information. Business in real time means that I need to analyze my data as it's happening. I may do this at a bank for fraud detection. I may do this in a law enforcement application where I'm trying to determine if criminal activity is occurring. There are lots of reasons why I want to know what's happening right now. This is distinguished between data that is used in an ETL process that may be available hours or days after the event occurs, which has its uses, but may not enable you to make the decisions that can save your business money or help increase profits. The second primary use case is what we call always-on information, and this is primarily high availability. I want to copy the data as it exists in one environment, one platform, one data center, one city, and I want to put that exactly as it exists in that first location in a second location. So if something bad happens, we can immediately respond by shifting our applications to that second data repository and have our customers served with no downtime. That's what always-on information is. So high availability, disaster recovery, zero downtime migrations. We just had a customer who requested information about how they could move from one operating system, one version of a database, one version of an application, and move to another. But it's an electronic wallet, an electronic payment system, and they don't want to take an outage for a half a day in order to do that. They want to continue to serve their customers, and there are ways to accomplish that. So, keeping data synchronized among applications will be one of the most prevalent use cases for data integration. So data integration has a lot of different applications, and we're going to see a little bit more about that in a second, but pure data replication, copying data from where it is generated by the system of record and sending it someplace else for some business reason, is going to be 50% of the use cases this year for data integration implementations. So what are some of the principles that guide our use of data replication? First of all, it has to be low impact. And so virtually everything that we're going to talk about is what we call log-based capture, meaning that whatever the data repository is in the source, it is being recorded in a log for recovery or unit of work back out or some other reason, and we're going to use that log, as opposed to writing an application or running a utility or doing something that is a bulk copy of data. So we're talking about as trickle feed changes, and your trickle may be a torrent depending on the volume of your transactions. We're going to be capturing that data and then moving it down the pipe to something else. We want it to be near real time. We want to have very low latency, if sub-second if possible, so that whatever the target is a complete and accurate representation of the source. Trusted delivery, once and only once. We want to make sure that we have the same data in the target that we had in the source, whatever form that data in the target takes. And one of the challenges that I've faced as a consultant is walking into a shop that did not have the governance in place to ensure that that was happening, and they were either making bad business decisions or they had gaps in their data. Their data was not complete and not consistent, and that happens a lot more than you might think. And then finally, enterprise scale to handle the billions of transactions that occur in a lot of our enterprises on a daily basis. Okay, before I get to the next question, I have a couple of raised hands and I have a couple of questions in the chat. So let me take a second to find out what they are. So happy birthday wishes for Kim, which is awesome. And
thank you.
There you go. Yeah, I don't know if you can see this, Kim, but I'll send them to you later on. They're all very cool.
Thank you.
A lot of people you know too. We have a lot of friendlies on the call today.
I can't see them, but thank you, and I hope to see them later.
I will send them to you later. That's good. So one question is, can we get a copy of the slides? And the answer is yes. What we generally do is we are recording this webcast now. I should have told you that earlier. But when the recording is complete, we'll post it on our blog along with the material so you can get the slides. I saw a hand raised too. Let me see if, no? Okay. Okay, let's keep rolling because we have a lot to cover. So I am going to go to the third of our polls, and I would like to understand your use cases. What are the purposes of replication in your organization right now? And again, this will be a multiple answer question because you may be using it for a lot of different things. Okay, the poll is open. So is it what I just described as business in real time or always on information? And we're seeing a pretty even, sort of bouncing around a little bit, but as they're coming in, we're seeing between 60 and 70% of the use cases are each. Analytics on current transactional data and always on information for high availability or data synchronization. Excellent. Well, thank you all very much for responding. Like I say, this helps us direct the conversation to your specific requirements. So, the Gartner Magic Quadrant for data integration tools. I hope you all are familiar. I'm sure you've seen a lot of Magic Quadrants in your days. The vertical axis is the ability to execute. The horizontal axis is the completeness of vision. This was a survey done in July of 2019, so it is the most current available. And the four quadrants are labeled. The upper right is called the leaders quadrant, and that is because they excel in both the ability to execute and the completeness of vision. And as you can see, Informatica and IBM cover the top spots. Now, there's one caveat that comes with this, and that is this was a survey of data integration tools. So from the IBM perspective, this includes tools like DataStage, information server, as well as replication. So this is not confined just to replication, and that may skew the results somewhat. The link in the lower left-hand corner is if you want to go out and get this. This is available for distribution. They go down the list of each one of these vendors and talk about their strengths and their challenges. So let's look at the strengths and challenges of IBM. So their strengths, according to Gartner, is the depths of the integration offerings. So IBM has a complete suite, rich functionality, lots of pre-built functions and connectors. There are a diverse array of delivery styles. So how do I get the data out there? So it could be data replication or batch processing and complex data integration to condition your data to add value to it as you are moving it to another platform. And then finally, IBM is IBM, brand awareness and market presence. They are one of the leaders in this space, and some of that is legacy. IBM has had a lot of enterprise data for a long time, starting with their mainframes in the 1960s, and so they have a long history of helping customers with these types of tasks. The two areas where IBM had challenges was complexity. IBM has a lot of different offerings, but a lot of choices lead to complexity. That is Henry Ford's dictum: you can have your Model T any color you want as long as it's black, and that's not the way IBM vends replication solutions. And the other is pricing. But that was, I read through the report, and there was a lot of comments regarding not only the expense but the complexity of pricing, and we're going to talk about that a little bit later on. So what is it that we're talking about? IBM's replication portfolio. So we start with the source application on the left. We have databases and logs to get the data from the database for any data that does not appear in the log, pre-existing data. We have some sort of capture component. We have a transport mechanism in the middle that moves whatever the data is from the capture to the apply. And then it could go a variety of different places. It could go to data stage. It could go to a data lake. It could go to Kafka. It could go to a database, the same database or a different database. But that's basically what we're talking about here. Whatever replication solution or replication implementation that we're going to implement from IBM or from another vendor is probably going to follow this same pattern. So IBM's replication products, and I'm going to lean on Kim a bit here to distinguish these for us. So there is IBM Data Replication, IDR, and IBM Infosphere Data Replication, IIDR. So Kim, could you go ahead and distinguish between those two?
Basically, the difference between those two is the pricing model. And when you were talking about the complexity and the pricing that Gartner had identified as an issue, this is IDR is a response of IBM's, which in my opinion is a very positive response. You can kind of look at this as, they're trying to make the punishment fit the crime in terms of pricing. IIDR is the original IBM replication offering that includes both QRep and Infosphere change data capture. And IBM bundled the two of those together, and the original price model was that if you were doing replication, you took the source and the target, all the sources and all the targets, and you licensed all of them. And we would have customers 5 years ago when people were first getting into analytics that would say, we have one Oracle database and we want to make, and we just want this one analytics database over here, and we want to do some replication. And they would have to license the entire Oracle database and this one little target over here, and it would end up being enormously expensive. So IDR, IBM Data Replication, without the Infosphere in the middle, is a different price model, which just has you're only licensing the source. So if you have a large source, like a large Oracle database, and you want to replicate to Postgres and DB2 for LUW and a million different targets, you're only going to pay for that source. So it's different. You're still paying for replication, but it's a different price model.
Got it. Okay, that's great. So if I have what I would call a broadcast requirement, where I have to send data on a system of record from one primary server, not limited to, but a mainframe would be a good example of this, then the IDR pricing model would probably work better for me.
Exactly. And when you see the proliferation of edge systems and obviously the huge growth of analytics, everybody needs the data that's coming typically from the production transactional system. And so if you're just going to license that, and you're going to be able to give your organization the ability to replicate to numerous edge systems, obviously IDR is the far better licensing model.
Excellent, thank you. So we'll get back into pricing and licensing a bit more later on, but I wanted to describe the products that you may have heard or about. We also have some other specific products, DB2 for ZOS remote capture, and we'll talk about that in some more detail later on, as well as the classic replication, and then finally the data replication for continuous availability. So the components, as Kim alluded to, there's a little bit of history here. IBM started with something called SQL replication. Sybase was the leader in replication back in the early 1990s when that was a thing. And IBM's response was something called Data Propagator. And I can't scan the attendee list right now, but I'm hoping a colleague from way back, formerly at the Healthcare Financing Administration, now known as the Centers for Medicaid and Medicare Services, CMS, a guy named Frank Cipollone, we worked on an implementation of copying data from an Oracle nursing home application that was in each of the 50 states and replicated that up to a data warehouse on an IBM mainframe. So that was 30 years ago. And that was the first way that IBM copied data from place to place. The transport mechanism in the middle was staging tables. And those staging tables were an intermediate landing spot. So the capture component that we talked about before read the logs of the Oracle databases and then landed those in staging tables. And another process, that is the apply process, would read those staging tables and move them up to the mainframe. So that worked. The problem was that I was landing data to disk in a database, which was being logged multiple times, and that wouldn't scale. So IBM's response to that was to take out the staging tables in the middle and put in a different transport mechanism, IBM's MQ messaging system. So MQ is the transport layer. The products are not exactly the same, but conceptually pretty much the same, except for that transport layer in the middle. And that transport layer made all the difference. So now we could scale to enterprise scale. We could have multiple queues, moving data from source to target, and a lot more flexibility, but a bit more complexity in terms of getting data from here to there. But the queue replication is used very frequently in the high availability scenarios because it gives the best throughput and the lowest latency to move data from source to target. And then finally, IBM wanted to increase the breadth of their offerings, and so they purchased a company called Data Mirror, which is now referred to as their Change Data Capture Suite, and that is primarily focused on what we call heterogeneous replication. So source and target are different, there are nuances between all these distinctions that I'm making, and if you have a specific use case, we can drill down on that. But these are the buckets that these are put in. There are situations where you would use queue replication for heterogeneous replication between Oracle and DB2. But those are not the most common use cases. So that's why we're trying to level set them for you. The transport mechanism in change data capture is TCP/IP. So it's just a straight pipe from source to target. There's no intermediate mechanism to manage that data. So in terms of sources and targets, this is an eye chart, but I put this here for a purpose. These sources and targets comprise all three of the components that I just showed you. Some do some do others, but within the suite of IBM replication, they can do all of these. And this is pretty much all the things that you would probably want to copy data from and send data to. As you can see in the supported targets, there are a number of cloud implementations, DB2 Warehouse on Cloud, Microsoft Azure, SQL Database, etc. So IBM Cloud. So this can actually be used in your journey to cloud. I need to take data from off-prem data transaction systems and move them to a cloud data repository where we do analytics. One that I want to draw your attention to, which is in the middle of the targets, is CDC Replication Engine for FlexRep, which is a JDBC implementation, uses JDBC drivers, which means that if your specific data repository is not here on this list, if it has a JDBC driver that it can access, CDC can drive that JDBC driver and move data into it. So I would be willing to bet a steak dinner with anybody on this call that you can't name a data repository target that I can't get to either with FlexRep or with IBM's Federation technology, which is the old Infosphere Federation server, used to be known as Data Joiner back in the day, but a broad coverage of source and targets. So we're going to look at some source and targets for broken down in our two different primary use cases, always on information for high availability. On the left, you can see DB2 to DB2, IMS to IMS, and VCM to VCM. This is data center to data center. I want to copy the data exactly as it looks, so I have a failover in case of catastrophe. And then IBM is moving towards differences within their product suite of copying data from DB2 Warehouse to their IBM Integrated Analytics System, IIAS, also known as Sailfish, which is their appliance. And the idea is to move data between those, again, for high availability. On the right-hand side, we see more of the business in real time, where I want to take data from a primary transaction processing system as it exists today and move it into some other repository for analytics. And just some more detail on this in the way that they work. I don't want to spend too much time on this because I'm hoping that most of you have gotten the message. So key features. So poll number 4 is IBM Z Systems. And back in the Gartner report, this is something that IBM excelled at, not surprisingly, because of the tight affinity that IBM has with their own data repositories, VCM, IMS, and DB2 for ZOS. So I'm going to go ahead and open the next poll to get some feedback from you on whether IBM Z Systems and which particular components of Z Systems might be of interest. So for those of you who are using IBM replication products and replicating data from IBM Z Systems, over 90% DB2 for ZOS. There's 15% of VSAM and maybe 12% of IMS. So not insignificant by any means, but the primary focus is on ZOS. So let's talk about that for a second. And I'll give the folks another few seconds to respond so we have a complete look. Okay, and let's talk about remote capture from DB2 for ZOS and the business value. So IBM for years has had a capture component that lived in the ZOS operating system. And that became sort of a balancing act of, okay, I need to get this data off of Z for other purposes, but I'm burning Z MIPS. And this became a problem for some shops. I've read statistics that the capture component of a product like DB2 for ZOS will comprise between 5 and 20% of the MIPS consumption of the database, meaning that I'm going to take a database that may be fully deployed right now, just doing transaction processing, and I'm going to add up to another 20% load and another 20% expense in terms of IBM Z processing in order to get the data off. So IBM's response to that is something called remote capture. The way that remote capture works is that the bulk of the processing for capturing the data is done off-platform on Linux. This could be Z Linux, this could be Linux, or this could be Red Hat Linux on another processor entirely. But the idea is I want to offload that capture demand for resources someplace else. So the goal is to reduce the ZOS MIPS consumption. And I have this box in here on my slide at 50%. The reason for that is when IBM first released this product, they said that people were going to experience up to 90% MIPS savings, and that just turned out to not be the case. So a more realistic goal is 50%. But if you are adding 20% MIPS consumption to a capture component in DB2 for ZOS and you can reduce that to 10%, that may be a good thing. You can also reduce dependency on specialized Z skills for deploying, configuring, and monitoring, because most of the work is being done off platform. So let's look at the way that this works. ZOS, as you see it on the left, contains DB2 for ZOS, works with versions 11 or 12. And then in the middle there, you can see LUW, that's a Linux, Unix, or Windows platform. I cannot imagine deploying this on Windows, but apparently you can. And the job of that is to format the data and send that down the pipe through TCP/IP, because this is built on change data capture, and sending that to any of a variety of CDC supported targets. So it could be Kafka, it could be another database. But the only thing that's actually happening on ZOS is that the LUW piece sitting in the middle is actually invoking a stored procedure on System Z to go ahead and read the log. It's actually doing the log reading remotely via the stored procedure, co-resident on ZOS, sending that data back to the Linux platform, and then on down the pipe.
And Frank, I'd like to add one more thing to this, and that is that in many ways, this is really a pricing play. For many customers, they actually, if you have a mainframe, you probably have somebody in-house who watches mainframe statistics like a hawk and is very concerned about anything that's going to add workloads. And so when they see this, they say, oh my gosh, this can save us so much money. The other thing with this is that you can target just about anything, and you're not going to pay more. So it's really a pricing play as well as a technology play.
Excellent. Thank you. Thank you for that expansive answer. Because I tend to be down in the weeds with the technology, and you know, we're running businesses out there, so we want to make sure that the business requirements are addressed as well. So 2 examples of targets that can be used, that can be provisioned with IBM replication products. And one is Hadoop, and the other is Kafka. So when Hadoop was first announced, a lot of people said, this is great, we can feed our data lake. But there were some problems. If you think about the way Hadoop works, the Hadoop distributed file system, it is based on ingesting huge amounts of data, but not trickle feeds, not the way that data is being generated at the source system. Number one. Number two, I'm not generally doing the analytics in my data lake running on Hadoop with exclusively or even primarily real-time questions. This is more a analytics over time, looking at time series data, look at changes over time. So that's one of the reasons that I want to be able to store a vast amount of data, so I can keep data for longer periods. So what I'm seeing from customers is that they are using Kafka as an intermediate landing spot. You are replicating your data from a source, and it could be DB2 for ZOS, or it could be something else entirely. And I want to land that data in Kafka and then have some other application come out and read the Kafka topics and provision that data to Hadoop in something like a mini batch. So maybe the data would be consumed from Kafka, the data would be provisioned in Kafka near real time, but the data would be consumed every minute or every 5 minutes. Make better use of your Hadoop resources and get the data in a fashion that makes sense. We had a number of customers come to us and say, Hadoop just can't keep up with the trickle feed. It's not what it's architected to do, and so it doesn't do it very well. So that's the comparison between the two. They can work together, or Kafka could be used something for a completely different use case. So I had a customer that I talked to this week, has a huge DB2 for ZOS data repository, wants to provision data for Kafka, have Kafka serve as an operational data store, an intermediate hub, and have a variety of different applications coming out to consume that Kafka data topics. And the data is being replicated once, the same piece of data, the same transaction, but there may be multiple different consumers coming out and getting that data from Kafka. So the benefit there is I don't have a series of point-to-point replication topologies going from the DB2 source and supplying the same data over and over again to different targets. I replicate that data off of Z once, it lands in Kafka, and all the different data consumers, which can change over time, go out and get that data. So a much more sane type of replication topology, save money and save MIPS. And so here is an example of real-time data feeds to Kafka. There are two write methods. One is the REST API and the other is the native Java. The targeted Kafka must be at the 0.10 standard. And you recommend, IBM recommends a schema registry service and corresponding deserializer that supports the Confluent API. So you can make sense and govern and administer this environment in a more sane fashion. You can also use the Kafka custom operator process, and that eliminates the use of a schema registry. But you can see the capture occurring on the left, the apply on the right, and then the apply going to either Hadoop directly or to Kafka for later capture. So what are customers doing with Kafka? I just described the architectural data hub in the landing zone, staging for data lake and other analytics platforms. I explained that one. Staging for cloud. So one of the problems that a lot of customers are running into with cloud is the latency because the analytics platforms that are being used in the cloud are consuming data that may be on-prem. And just the law of the speed of light, there is some built-in latency getting to a data center that may be hundreds or thousands of miles away, administered by another vendor and you may not even know the physical location of where that data resides. So being able to provision that using the intermediate landing spot of Kafka makes a lot of sense. The data is replicated to Kafka and manipulated, and either the results or the original data is copied to the cloud, or the data can be written to a cloud-hosted Kafka for enterprise analytics use cases up there. So the Kafka can reside either place. It can be on-prem or it can be in the cloud. Postgres. Postgres is so huge that even IBM is doing Postgres. So IBM is now collaborating with enterprise DB's distribution of Postgres. IBM released the IBM Performance Server, IPS, which is a Postgres platform to take the place of Netezza. So IBM is all in on Postgres. And so they developed a Postgres capture engine to get the data out of Postgres and send it where you need to be in the format that you need it to be in. And so that capture is available today. So if you are embarking on your Postgres journey, know that Postgres is a supported capture, native capture for IBM's replication. Continuous availability. So we talked about this before, and we talked about that IBM is doing the like-to-like and also the like-to-different, IIAS to IIAS or DB2 warehouse to IIAS and back and forth. Provides transactionally consistent asynchronous DB2 replication for a near real-time mirror. So this is a high availability of play. Both the primary and secondary are active, so you can use them for load balancing, if you will. You can go back and forth between the same platforms. And I think before I get to upcoming enhancements, I want to go ahead and check the chat queue to see if there are any questions, anything that I've missed. So let me see. I do have a few that came after the happy birthdays. Does IDR support Postgres as a source? The answer is yes. So there is a question from Guy in Belgium about whether Oracle would require the use of triggers to capture the modifications, and no. IBM does not. I think other vendors like Oracle have used triggers in the past. I don't know if they still do, to gather the changes that are occurring in the database source or the system of record. And IBM's replication technology is all log-based, so there's no requirement for triggers in order to do that. Question about Z System. Didn't have an option for none, using it for DB2 for LUW. Okay, fair enough. So I'm assuming that Bill Hackett is running DB2 for LUW on Z Linux. And if you could post in the poll, and if you got my surmise, that is a Z System use, but not using ZOS resources or components. And it says, may I know the name of the SP name, which is invoked from the Linux capture? This is for IBM's remote capture. I don't know it offhand, but I will find it out for you and follow up with you later. And it says, can you run the stored procedure on a zip, from Luke, also in Belgium? And the answer is no. I asked that question too. It is not zip offloadable. I thought that would have been a great thing for IBM to do, but they gave me a whole bunch of reasons why they can't. So the stored procedure invoked by DB2 for ZOS remote capture is general purpose processor running. And I thought that since the request originated off platform and the traffic through the DB2 for ZOS distributed data facility is zip offloadable, that stored procedure would be, but the answer is no. Now, this may be something, this is not a technology question, this is an IBM business question, and I would say that if enough customers rise up and say, make this stored procedure zip offloadable so we can save money, then maybe IBM will do it. That could be a request for enhancement, which I'll talk about in a little bit. So let me see. So a question, let me see. By enabling remote capture, doesn't a customer simply shift MIPS processing from a potential capture on Z to a workload management task running the stored procedure to capture the data? And the answer is yes, but some, not all. You're reducing it by 50%. It's not. There's no free lunch. You're still running some Z processor consumption of the data originating there to read the log. Let me see. And how about replicating sequences? They are not logged. This becomes a challenge, from Samuel Pizarro. So Samuel, I have to take that offline to find out more about what you're talking about. If you're talking about the creation of sequences in DDL, yes, those are not logged. That would have to be done in some other fashion. And the answer from Bill Hackett is yes, they are running DB2 LUW on Z Linux. Okay, cool. So I will go ahead with the presentation on to the upcoming features, the new stuff. Kim, could you give me a time check? This covers up the clock in the lower right-hand corner. And I put my phone away.
You are at 11:47.
Perfect. Okay, we should be able to bring this puppy home. So upcoming enhancements. So the first is the remote capture for vSAM. So IBM is going to do the same thing for vSAM that they did for ZOS. And that is going to be available in June of 2020. IBM has announced it. It'll be GA then. It also contributes to MIPS offload. It requires vSAM logging, and way down in the weeds beyond the scope of this discussion about vSAM logging, but we can talk about what the requirements are. But if you currently replicate vSAM data, or if you think that that would be a good idea, I'm working with a customer right now who's considering it, that has vSAM as a strategic data repository and has for the last 30 years. They're going to be very interested in this. This is going to have early availability and a beta that's out now. If you're interested, let me know in the chat or send me an email, and we will make sure you get the information about it. So I have a bit of a tease here. The next one, the integrated synchronization. There is a presentation by Namik Hurley, IBM Fellow, next Wednesday, so 6 days from today, and the link is there to be able to sign up for that. But it's being advertised as accessing DB2 for ZOS data without accessing DB2 for ZOS. And I am piecing together what I know. I am not disclosed to discuss it in detail because it hasn't been announced yet. But IBM is using something called integrated synchronization to move data from DB2 for ZOS to the IBM DB2 Analytics Accelerator today. And the primary difference for integrated synchronization is that in every other capture process that IBM uses, the data must be transactionally complete before it goes down the line. That is, if I see update, 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 update in the log, all of those are gathered primarily in memory in the capture component, and I wait until I see a commit for that data to go down the line. Now, we have what I call the elephant in the snake problem, where if I'm running a transaction that updates 1 million records, and we have customers that do that, all of that data gathers in memory at the capture, and then we see the commit, and then 1 million record updates go down the line. And that leads inevitably to some latency. The way that integrated synchronization works is that it can deal with rollbacks, meaning that you give me an update, I send an update down the line. You give me another update, I send it down the line. If I get a rollback, I go back to the target database and I roll those transactions back. No latency. So I think that that's the secret sauce of what is going to be a Nomics presentation. But if you're interested and curious, as I am, I encourage you to click on that link and register. So tooling, I don't have as much here as I would have liked. I'm a little disappointed. I'd reached out to the IBM offering managers. IBM has struggled with tooling throughout their suite of data management products for decades. This is just me being real honest. I remember something called Data Hub that was announced in the 1990s that was going to be the be-all and end-all for not only IBM databases, but for Oracle and Informix and all sorts of stuff. That never happened. Then there was Control Center, which spawned Replication Center. Then there was the Q Replication Dashboard. So all of that is going away. The Replication Center and the Q Replication Dashboard are going to be, well, the Replication Dashboard already has been deprecated. The Replication Center is going to go away. And what is going to replace that is some combination of the Watson Knowledge Catalog, the Watson Studio, and the Enterprise DB2 Unified Console. So I only have an example of the last one to show you at this point. And what I may do is a blog post as I get some more details on this. I had reached out a couple weeks ago to the folks at IBM and say, give me some examples of the feature functionality and how's it going to work, and I didn't get any. But this is what the integrated console looks like, and so you would be able to manage your replication topology from this interface that comes, in this case, as an example, from the IBM Integrated Analytics System. That's the appliance that runs DB2 for LUW with Blue Acceleration. So more to watch in this space. I don't have a complete answer yet, but I did want to let you know what's coming, especially if you are depending on things like the Replication Center and Q Replication Dashboard. They are going to have to be replaced, and there is probably not going to be a migration path. So be aware. So last poll. We are just about to wrap up. I know I have less than 10 minutes at this point, but I am going to say, of the things that we've discussed today, of the IBM replication solutions, which sounds the most interesting to you? And so this is a one answer. This is not pick as many as you want. I wanted to find out what tickles your fancy. So, leading the pack are replication from IBM Z Systems and continuous availability. Those are the two that seem to be the most interesting, with Kafka as a strong third. Replicating from Postgres, not much interest at this point, and less than 10% for other. So thank you. Thank you for your responses. This is good intel. I'll give folks another couple seconds to go ahead and respond to that, to have their vote counted. And I'm going to go ahead and we're still getting responses trickling in. Thank you. And we're getting a good showing too. I mean, 2/3 of you are taking the time to respond. So I really appreciate that. So I'm going to go ahead and close this, and Kim has a couple of things that she wants to talk to you about. Well, before we get to that, what are the things to consider when determining what is the right replication solution? First is cost. At the end of the day, it's all about money. And the costs come in a variety of different ways. It's the software licensing and maintenance costs, because you don't just pay for it once. The implementation costs. We're working with a customer right now. We're probably going to spend 1,000 hours with them setting up some queue replication topologies to move data from a transaction processing system into an ODS. And then the BAU, business as usual processing cycles. You're going to be paying for running that stuff. Some other considerations are the data volume. How much data are we talking about? Are we talking about relatively low volumes, or are we talking about millions of records a day? What is your tolerance for data loss? And I ask this question, and people say, well, we want all the data. Well, maybe. Obviously, if you're dealing with a financial system, you can't afford to lose records. But if you're dealing with the Internet of Things and you're copying data from numerical processing or factory floor, I may be able to lose some of that data and not suffer any ill effects. So consider that, because capturing 100% of the data is expensive. And, it could be that the 5% between 95% of the data or 98% of the data and 100% of the data, that incremental addition of data could lead to considerably more expenses. And you may want to try to balance that off with your need for data accuracy and whatever the downstream application is. Where do you have skills? That's very important for determining the platform on which to implement a solution. So looking at remote capture for DB2 for ZOS and now vSAM, I can implement that one of two places. I can implement it natively on Z, or I can do it off platform. Where do I have the skills to do that? Simplicity versus complexity. On Occam's razor, all things being equal, the simplest solution is probably the best, but you may have to introduce complexity in order to achieve your business goals. And then finally, risk. If I don't replicate from the system of record, if I don't have a high availability solution in place, if I don't have an active solution in place, what does that mean to my business if we take an outage for a minute, an hour, or a day? No answers to that. Those are things that you're going to have to come up with in a matrix. And now I will turn it over to Kim with the how to buy story.
Thank you, Frank. The how to buy story is really pretty simple. The actual determining what to buy can become complicated. When we talk to customers that are looking at replication solutions, the first question we ask is, what are the sources and what are the targets? And what are the sizes of those sources and targets? And that's really the most important thing you can determine upfront. And then also, when you start looking at what you're replicating, are you going to be doing replication from point A to point B or both ways? And then you have to look at the different IBM offerings. The IBM offerings are complicated, but they're complicated for a reason. There are so many different scenarios, and you want to get the offering that meets your SLAs and what you're trying to accomplish, but you also want to find the offering that is the least expensive to purchase. And Frank and I talk all the time about, who is the perfect customer for the Fillmore group? And of course, the perfect customer comes to us and says, why, budget is no issue. We really don't run into that many perfect customers anymore. And so it's really important that you drill down as closely as you can to determining exactly what it is you're going to be doing, and then take a look and then compare that with the IBM offerings, because IBM has made so many different new offerings, but those new offerings are really simply ways to align with what customers are doing and to enable customers to do what they need to do affordably. And we want to help you do that.
Excellent.
So one other thing that I asked Frank to include in this presentation, this is the nuts and bolts. This is not the most exciting thing in the world, but there are different metrics that IBM uses for pricing. And a basic understanding of these can make a huge difference in what you're trying to buy. So if you're interested in learning more, if you're looking at just getting, a ballpark pricing, do a sanity check. We want to just get some idea of what this is going to cost. You're going to need a little bit of understanding of what processor value units are, what resource value units are, and resource value units are based on mainframe MSUs, and there's a calculation, and understanding what a virtual processor core license is. So I think this is important, and if you're at all interested in digging into this, I would be more than happy to work with you.
Great, thank you. So our wrap up, number one, resources and contacts. So if you need help with any of the questions that we have raised today in terms of implementing replication technology in your shop, whether it's architecture, whether you have an existing solution that needs a health check, whether you need a version upgrade, and this is very important. The only version that is currently supported of Infosphere data replication is version 11.4. Version 11.3 has been out of service since last September. So if you're running an unsupported version, you could not only run into technical problems that will be hard to solve, but you could be run afoul of regulatory issues. Core technology components need to be supported by the vendor according to certain financial regulations, or they need to be reported in financial statements that you are not. And CFOs don't like having to report stuff like that. So, and finally, IBM authorized training, both for change data capture and queue replication, if you'd like to get your folks up to speed on how to use the technology. I want to point this out for a second, the detailed roadmaps. IBM is externalizing a lot of their decision-making these days and listening to customers more. So each of the components of the data replication portfolio has its own roadmap, which I have linked right here. You can click on these links and go out and see exactly what is being proposed and what's coming. If it's something you need, if it's not something you need, you can submit a request for enhancement. So you go to the AHA platform. You can go to this link, but IBM uses that for collecting what used to be called RFEs. This is a broader platform that supports lots of vendors, I believe, and we've had some success with it in posting RFEs and actually getting IBM to agree to consider and implement them. The last two that I want to talk about down here are the data replication community and the data replication community wiki. IBM has deprecated their DeveloperWorks platform that was around for decades. This is where people would post blog posts and trial code and presentations and all sorts of stuff, and all of that has gone away. So if you're used to going to DeveloperWorks to find stuff, now go to the link that I have in here, the data replication community, and then the wiki has a great collection of stuff. Again, the trial code, some specifics on sources and targets for replication. So lots of useful information. I recommend both of them to you. And with that, when you leave this webinar today, there is a brief 4-question survey. If you could take a moment to respond to that so we can get some feedback on how useful this was to you today. Thank you very much, Kim, for your contributions, and happy birthday.
Well, thank you, Frank.
You're welcome. So with that, we'll go ahead and close this down. Please stay safe and healthy, everyone. We live in strange times, but I hope we all come out on the other end of this as well as possible. Take care.